Okay, so today's Discrepant event video will be melting ice below freezing. So I started out by putting this measuring cup in the freezer so that it doesn't have any outside forces acting on it to heat up the system in which we will be putting in the ice. And I will fill this 1/3 of the way full with ice. Alright, so that's about 1/3 of the way full. As you can see, there is no melting occurring at this point. And now I will add in the 3 teaspoons of salt. Alright, we added in the 3 teaspoons of salt. Now let's fill the rest of the measuring cup with the ice. Alright, and let's watch what happens here. As you can see, the ice is beginning to slowly melt. You see the residue in the liquid water forming at the bottom. As you can see, the ice is beginning to melt there. And the freezing or melting point of salt water is much lower than that of pure water. The addition of salt to the ice at 0 degrees Celsius causes it to melt because salt water cannot freeze at 0 degrees Celsius, just as pure water does not freeze at 5 degrees Celsius. So the melting process decreases the temperature because melting needs heat. And as heat was not supplied to the system of melting ice, it withdraws heat from its own environment. Just as the forced evaporation of liquid without any heat supply will have a cooling effect, this decrease in temperature is a result of a forced melting process, also called freezing point depression. This is why in colder climates, salt is used to melt ice on slippery roads in the winter. Again, this is Nakia Johnson, and thank you guys for listening.